We saw that we get perfect reconstruction in a filter bank using ideal filters. Ideally, we remove all aliasing components. But in practice, we don't have ideal filters. They're not realizable because their impulse response stretches from minus infinity to infinity. How can we obtain perfect reconstruction using realizable non-ideal filters and still critical sampling, meaning the downsampling rate capital N is equal to the number of subbands, as in the case of ideal filters? Let's first take a look at the resulting spectrum when we use non-ideal filters. We start with the spectrum at the output of non-ideal high pass. We have here a non-ideal part. Observe that the slope at pi divided by 2 and minus pi divided by 2 is not infinite, but we get a more or less slow transition into the higher attenuation towards lower frequencies. Hence, we also get frequencies below pi divided by 2 or above minus pi divided by 2 in our signal. This will become a problem after downsampling by a factor of 2. For now, just the multiplication with the delta impulse train, as can be seen in the next pictures. Remember that for the multiplication with the delta train, we get aliasing components at frequency shifts of 2 pi divided by capital N, hence in this case pi. So here we have the overlapping of aliasing components. Observe, even if we now used ideal filters for the synthesis for the high pass part, we would still have the overlapped aliasing component and hence no perfect reconstruction.